right, guys, so if we jump straight into it, what we're going to start with is just recapping how we actually determine the area of basic shapes and these are sort of formulas that you need to know. In grade 8, we might still give you the formulas, depends how nice your teachers are, but we do expect you sort of from grade 9, grade 10 to know these formulas off by heart. We won't give you these formulas. So this is an important sort of information sheet to have for this section. Okay, now there are 4 basic shapes that we need to know how to work out the areas of. Those are squares, rectangles, triangles. Oh, sorry guys, don't know what happened there. Squares, rectangles, triangles, and circles. So we need to know the areas formulas of those 4. Now the first 2, you can sort of actually use the same formula if you want to, but there are specific area formulas that we can write down. For squares, the area is equal to, and what we need to remember about a square is that all of these side lengths are the same. And so the area of a square is equal to side times side, or we can just shorten that to side squared. If we then go on to the rectangle, a rectangle has 2 pairs of sides that are equal to each other. We call these sides the length and the breadth, or you can call it the width. It really doesn't matter. But then to work out the area of our rectangle, we would take the length times the breadth or the width. Doesn't really matter, whichever one you're going to choose to use. So those 2 formulas, I feel like 90% of us know. Remember, we've done them multiple times. It's in the area of the triangle and the circle that potentially we get a bit stuck on. So the area of the triangle, there are 2 important dimensions that we need to know. So the area is half times the base times the height, and those 2 sides are then the base length and the height. Now your base length of your triangle is generally going to be the bottom side. It doesn't always have to be the bottom side, and you'll see that in one of our examples in a second, but it's basically like the base length, the sort of length on which the other lengths sort of come off of, for lack of a better description. It was a terrible description, but it's the bottom. Right, we then have the height of our triangle. And very importantly, the height of our triangle is always measured from the topmost or the highestmost point of my triangle down to the base at a right angle. So importantly, it is the perpendicular height. So like I said, always measured from the topmost point to the base at a right angle at 90 degrees. Okay. Finally, we have our circle. Now, I've said before, but I'll say it again. Whenever we are working with a circle, in terms of any sort of measurement, whether it's area, circumference, when you eventually start talking about 3D shapes, volume, we're going to work with pi. And so the area of our circle is equal to pi, that's a weird looking pi, pi times r squared. If you want to write this out and expand it a bit more, you can say pi times r, but basically pi r squared is the formula for the area of a circle. Now, some people at school have been told to write pi as either 3,14 or 3,142. You obviously do what you've been told to do. Otherwise, you just use pi on your calculator. It doesn't really matter. As you sort of move up in maths, you'll generally use the pi button. If you eventually decide to do maths lit, you will be told to use either 3,14 or 3,142. But we have pi in our formula. And like I said, generally with circles, we're going to have pi in the formula. So those are your 4 sort of basic but fundamentally important area formulas that you need to know. So I would take a screenshot of this just so that you have all 4 area formulas so that we can eventually go and apply them in our examples. So I'll give you a second or 2 to take a screenshot, and then we're going to have a look at some examples. Hopefully nothing here is new. The only thing I just want to add to this is the fact that whenever we work out area, or whenever we are working with area, it is always, or the value of the area will always be in units squared. So that might be centimeters squared, meters squared, millimeters squared, whatever it might be, but it's always squared when we work with area. If we're working with perimeter, it's just the unit. So centimeters, millimeters, meters, whatever it may be. All right, I'm going to give everyone another second or so to take that screenshot, and then I'm going to move down to our examples. Alrighty, so let's have a look. Our first example here, I don't want to say is a word sum because that's not it, but it's giving us information about a shape. So it says the area of a square is 42.25 centimeters squared. So if we've got our square, there it is, we know that the whole area of the square, so basically the amount of space the square takes up is 42.25 centimeters squared. They are asking us to determine the length of the sides of the square based on or using that information. So this is the information that we have. We also know that a square's side lengths are all equal to each other. Now, I stand to be corrected. I feel like we did some examples like this on Wednesday, but I could also just be imagining things. But let's have a look and see how we would do this. Firstly, we know that the area of a square, is found by saying side squared or side times side. Doesn't really matter. And if we substitute in what we know that the area is 42.25, and we are looking for the side length. And so just by substituting into my area formula, I can start to solve for my unknown. Now the unknown here is that S, and because this is S squared, what I want to do is I want to square root. By square rooting S squared, I cancel out the squared, but what I need to remember is that because this is an equation, what I do to one side, I have to do to the other side. And so when I go and square root 42.25, as Tolile has put on the chat, we get a side length of 6.5 centimeters. Now, very importantly, guys, because this is just a length, it is not centimeters squared, it is just centimeters. Okay, so we can work backwards from a given area in order to work out a length of a side that I've been given. So I'll let you take a screenshot, but then I'm actually just going to give you another two like this and slightly challenge you a little bit. So I'll let you take a screenshot, and then I'm just going to move to the side to put them down. Okay. Oops, I don't know. Weird things are happening. Okay, yeah, that's fine. Area of a square is 90.25 centimeters squared. Panic. Determine the length of the sides of the square. So very similar to what we just had a look at. And then the next one I'd like you to try, I just have to get my numbers right. Okay, so those are the two questions I want you to try. The area of a square is 90.25 centimeters squared. Determine the lengths of the sides of the square. And then question C is a little bit trickier. The length of a rectangle is triple its width. So the length is 3 times as long as its width, or you can say breadth. if the area of the rectangle is 27 centimeters squared, determine the length and the width of the rectangle. So I'm going to give you guys a few minutes to give that a go. If and when you have an answer, you're welcome to raise your hand or put it on the chat. You can just put your answers B and C so that we know which is which. Remember your units and remember your formulas that apply to each of these. Lolita, do you have a question for us?
Oh, ma'am, I wanted to answer B.
Okay, cool. I'm going to give everyone another minute or two, but then I'll come back to you. And remember, guys, sometimes it's useful to just draw the shape that you're working with. So if you're struggling a little bit, try and draw it for yourself, and then you can start to like put information in and try and see if by visually looking at what you've been given, if that's helpful to you in any way. Give everyone another minute or so. I see there's some hands starting to go up.
Doing great, my pebs. We can see the coming answers.
Okay, Lolita, do you want to do B for us?
Yes, please, ma'am. So
Okay.
for B, I said 90, 25 is equal to S squared.
Cool.
And then in order to get S alone, I square rooted S, which S squared, which gave me S. Then I did the same to 90, 25. And the answer I got was 9,5 centimeters.
Perfect. Right, so guys, importantly, it's centimeters. It's not an area, it's a length. So it's just centimeters. And by square rooting, I've worked out what one of these side lengths of my square is. Now, remember, you can double check yourself. You know what the area of the shape is. So if you now take this answer and you substitute it into your area formula and you say 9,5 squared, you do get 90,25 centimeters squared, which is the area that I gave you. And so you can double check that you've done it correctly by taking your answer and using the area formula. Right, very nicely done. Emmanuel, I still see your hand up. So are you going to want to try C?
Yes, ma'am. Thank
Okay.
you. So I said A equals A equals B times L. No, what?
Yeah.
Yeah, B times L. Sorry, yo.
Or length times
then,
breadth, either way.
Yeah, and then I said 27 squared. Yeah, 27, sorry. 27 equals 3B, and that's for the length. And then I said 3B, I said 3 divided by 27 divided by 3, and 3 divided by 3, and that gave me B equals 9. And yeah, that was the final answer for the length. Okay.
Mm-hmm.
And since the length is 3 times the width, I said 9 divided by 3, and I got 3.
Okay. Let me just make sure I'm following. Okay, that was like 99% correct. Can I just double check something? When you said
Yes, ma'am.
3b, you're talking about the fact that the length is 3 times the breadth.
Yes, ma'am.
Okay, so this length is 3b, but what about that breadth? Don't we still have to times that by a b?
Oh,
Do you know what I mean?
oh, okay, yeah.
Your answers
Yes,
are
I see, I
perfectly,
see.
yeah. Your answers are perfectly correct. We just have to remember that one little step. All right, so guys,
Yes,
very importantly, it's so the 3b is basically because one breadth is then, no, sorry, let me start that sentence again. One length is triple the breadth. So if breadth is b, 3b is the length. And so if we substitute that into our formula of length times breadth or breadth times length, doesn't really matter, we've got 3b times b. And so this is now where we have 27 equals 3b squared. And you will see Emmanuel's answers were perfectly correct. We just need to be careful of our method. And so Emmanuel said that we need to divide both sides by 3, which is perfect. I don't want the 3 in front of the b squared, so that makes sense. So I'm going to say 27 divided by 3 and 3b squared divided by 3, which means that I've got 9 is equal to b squared. Now I don't want b squared, I just want b, which means that I need to square root both sides in order to get rid of that squared. And so that then means that the breadth of this rectangle is equal to 3 centimeters. And then going back to sort of what Emmanuel was talking about, if I know that the length is triple this, I will just take that value and times it by 3 in order to triple it. And so the length of this rectangle is 9 centimeters. So I've worked out that my breadth is 3, my length is 9. Again, I can go and double check that. If I go and take those two values, 9 and 3, and I substitute it back into my formula, 9 times 3 is 27. And so I have worked out the correct values for my dimensions. This was a hard one. So if you struggled with it, that is absolutely fine, and struggling is good. But hopefully now it makes sense of how to do it. So I've just made it a bit smaller in case you want to take a screenshot. You can now see both of them together, but do take your screenshot and we'll have a look at another one. Okay, I'm going to give you another second or so. Okay, let's have a look at another type of area question. So another type of question that we like to ask is sort of more complex or compound shapes. So we like to ask questions where I give you the area and you have to work out an unknown length, or we like to ask you questions where the shape is not just a rectangle or not just a triangle, whatever the case is. So here we've got a slightly more complex shape that we're working with. So when I say work out the area of the shape below, I'm panicking clearly. I'm asking you to work out the area of this whole T shape here. Yeah, this is a wildly thick highlighter, but anyways. So this shaded bit, that is what I want the area of. Now, this isn't just a rectangle or just a square. It's a complex shape that I'm working with. And so sometimes what we need to do is we need to break the shape up into rectangles or squares or triangles or circles or whatever it is in order to work out individual areas that I can then add together. So the only thing I'm going to say here is we need to break the shape up into shapes we're more comfortable with. And the fact that all of the dimensions here give me enough information for all lengths of this shape. So this 4 centimeters is telling me that this sort of overhang of the T on both sides is 4 centimeters. And if we know the whole width of the T is 15 centimeters, that then means down at the bottom, this whole width of the T must be 15 centimeters. Now on each side, I already have 4, which means that this middle bit is 7 centimeters in width. I can then use the same thinking to work out sort of the height of the base of the T, because I know that the whole height of the T is 9. I know that the height of the like T bar at the top is 3 centimeters. And so what I'm missing to make up the whole 9 centimeters is then the 6 centimeter height of the bottom bit of my T. So I'm going to give you guys, let's say, a minute to give this a try. My hint to you is try and break this up into shapes that you know the formulas of. So try and break it up into maybe rectangles or squares or whatever the case is. Because once you know the individual areas, you can go and add them together. Right. So give it a go. I just need to run and get some water because I clearly have a frog in my throat. And when I come back, we'll have a look.
Let's go, my babes. We can do this. Let's go. I see you, Leah. You are focusing. Go, girl. Let's see. I'm going to be your cheerleaders, guys. Let's go. We are doing this. Alessa, all the best to you. Y'all are gonna do well. Okay, are we ready?
Okay. Back. Right, guys. Lolita, you're going to tell us.
So I split it up into like the top part of the T and then like the bottom parts.
Okay.
So for the top part, I said A equals 3 times 15. And then I got 45 centimeters. Then for the bottom part, I said A equals 7 times 4. No, sorry, 7 times 6.
Good.
And then I got 42.
Good.
And then I added them together, which gave me 87.
Perfect. Well done. 87 what? What should my units be?
Centimeters squared.
Perfect. Excellent, Lolita. Okay, so guys, we're going to break our shape up into 2 rectangles. You could have broken it up into many different, the word I'm looking for, many different smaller rectangles. But the quickest way would be in 2 rectangles. So the top sort of bar and then the bottom bit of the T. The top rectangle has a length of 15 and a width of 3, hence 15 times 3 or 3 times 15, doesn't really matter. And the bottom rectangle then has a length of 7 and a width of 6. Multiply them together. And once we have those 2 areas, what we then need to do is we then need to add them together to get our total area of our shape. And so this is something that we need to be able to do. We need to be able to take complex shapes like this and break them down into shapes that we're more comfortable with or shapes that we know the areas for, so that we can go and work out a total area for our shape that we have. So take your screenshot and then we're going to have a look at our brain break, and then we will have a look at some more examples. Yo, this is what happens in exams. You don't teach and then my voice is just gone. Just don't talk to anyone.
Her voice is not used to it anymore.
No. It's like the first week back at school after the holidays, your voice is just so sore. It has to like retrain itself. Okay, guys, I'm assuming we all got a screenshot. I'm going to go down to our brain break. Oops. We're going to do it the same as always. First person to get an answer, pop it in the chat, let us know. We're going to mix up our brain breaks from Wednesday because I fully acknowledge that we've done these a lot. So we're going to mix them up from Wednesday. So let's see who can give us an answer today. We wait in anticipation. First person to put it on the chat is going to explain it to us.
Yes, let's go, my peeps. Let's see. Remember, take your time. Realize that there's a lot of differences there. We have a multiplication, we have addition, we have two of things. We Romeo, this is oh, you don't understand the joke. Let me explain it. So the joke, guys, while you're busy calculating, you know what it seems odd, okay? What it seems odd to me, it's numbers that can be divided by 2. Remember that? So guys, it's a funny joke because the reason it's a joke, it's because that any number that you divide that cannot be divided by 2, it's an odd number. So for instance, 5, it's an odd number because we cannot divide it by 2 without any remainder. 3, it's an odd number. So it's just so obvious. It's a joke on its own because it's a lame joke because it's obvious. But it's a funny joke because it's lame. So Romeo, I hope you understand. It's quite a good one. Raugelo, nice try. It's not 80. Oh, Raugelo is doing the. Never mind, Raugelo. Yeah, you're doing the last question, Raugelo. Well done. We are on our break, our brain break. So Raugelo, I know that you knew. So every it depends. In our 30 minutes, yeah, in our 30 minutes, we basically just do a brain break. We call this guy Brian the break. So we practice in our mind to do something else than what we are doing, what we are learning. So it's still math, but it's sort of fun because you need to find out all these numbers. So this is for fun. Hopefully, wherever you are stretching, you are drinking water, and you are coming to calculate so we can find the correct answer, okay? We're not finding area, we're not doing anything. It's just some fun thing that you need to calculate. So for all of you who are new, yes, so you basically need to see there the pattern. You see that we have these blue things and there's 2 plus 2 plus 2 of those things. So you need to find out what each or what 2 pairs or each cost in order for you to get 54. And you also need to find the second line, the third line, and then only give us the answer of the last line where the question mark is.
Theo
Fine, I see you. The winner is Theo. Well done, Theo. Well done, guys. Today's winner of Brian the Break is Theo. So Theo, you own Brian today, okay? Theo, Brian is yours for today. We will see on Wednesday who's winning. So Theo, can you please raise your hand so that you can explain to the entire class how did you get Brian the brain to be yours? How did you get the correct answer? You want to raise your hand, Theo? There we go.
There we go.
Hello, ma'am.
Hi, Theo.
So ma'am, I said 54 divided by the 6 snowflakes, and then I got 9.
So 1 snowflake is 9.
Yes, ma'am.
Okay, so 2 is
18.
good. Okay, keep going.
And then I said 25 minus 9, which was from the snowflakes.
Mm-hmm.
And I said divided by 2, and it gave me 4.
Yeah.
And then by the next one, I thought to myself, what times 4 would give me like a number, then plus it again, which was like 6.
Good.
And then I said 9 times 12.
Why 12?
Because the 2 3s,
Good.
6 plus 6 equals 12.
Good.
Then I got 106. Then I plus it by 8.
And why 8?
because 2 reindeers, 4 plus 4 equals 8, ma'am. Then I got
Good.
116.
Perfect. Excellent. Okay, so guys, sorry, this is how we do our brain break in this case. What we needed to be careful of here is that in some of these pictures, as Yolanda told us, there was 2 snowflakes in some, whereas there were only 1 in others. Same with the Christmas tree and the reindeers. And so we just needed to be mindful of that when we went and did this. However, as Theo has correctly told us, our final answer here is 116. So just be careful of how many of each thing you're working with, and just be careful of the actual operation that you're needing to use. But this is just something fun. Give it a try. If you don't get it, it's not the end of the world. It's just something fun to try. Okay, I'm going to assume that no one wants a screenshot, but I'll leave it here for like 10 seconds if anyone does. And then we're going to scroll on up to the rest of our area questions to give them a try. Okay. Right, so our next question says, determine the area of the triangle below. Excuse me. Now, importantly, we need to know which triangle it is that we are referring to, and it's the triangle that's sort of got the solid outline. So it's this triangle MRN, the one in pink. Now, we know that to work out the area of a triangle, we need to have the base length, and we need to have the height, because the area is half base times height, or half times base times height. Now, what might be useful is to imagine this triangle in a slightly different orientation. So what might be useful is to imagine the triangle sort of drawn like this. Not the most beautiful triangle in the world, but it's there. Right, so if this is my triangle, and it's exactly the same, I've just sort of like flipped it around. This is going to help me because now I can see that this length MN is my base length. And we spoke about these sort of weird looking triangles in our last lesson, because we spoke about the fact that the height of a triangle is always from the highest point down to a 90-degree angle with the base. Now, it doesn't matter that this 90-degree angle is not on the base. It's still at a right angle to the base. And so it still measures from the highest point of my triangle down to the base. And this was given to us as 8 centimeters. So I have the height of my triangle, but I do not have the base length of my triangle. The only information I have is that this whole length from M to P is 14 centimeters, and the fact that the length N to R is 10 centimeters. Now that's fine, because this actually does help us. What this allows us to see is that we have got a right angle triangle NPR, and we can go and work out the length of NP using Pythagoras that we can then go and use to work out the base length. So if someone maybe wants to give it a try, what would the length of NP be using Pythagoras? You can pop it in the chat or you can raise your hand. What is this length of NP? Sure. Right, Emmanuel's guys. Emmanuel's put it on the chat there for us. Theo has as well. It is 6 centimeters, just that you can see how it would be done. Hypotenuse squared, which is 10, is equal to 8 squared minus NP squared because of Pythag. So this would be 10 squared minus 8 squared, plus, which means that NP squared is equal to 36. We know that we need to square root both sides in order to get NP alone. And so NP is equal to 6 centimeters. Now that I know that this is 6 centimeters, I can easily go work out my base length, because I would just take 14 minus 6, and that gives me 8 centimeters. So now I've got my base and I've got my height, and so I can easily go and work out the area of my triangle. Area is equal to half base, which is 8, times height, which is also 8. And so the area of this triangle is 32 centimeters squared. Now, this is a good example of sort of area questions that we often like to ask, because we are relying on, or we're expecting you to do calculations before getting to the area. This is one, or these are sort of the types of questions that we often ask, where we expect you to use things like Pythagoras beforehand to get an unknown length, and then go and work out your area. All right, so I'll leave that up there if anyone wants to take a screenshot. I can see Lolita's hand is up. Lolita, do you have a question?
Yes, ma'am. I just wanted to ask why we subtract 14 from 6.
Okay, so we have to subtract the 6 from 14 because the 14 is the whole length. So if we go back to the original triangle, the whole sort of bottom length here is 14 centimeters. I only care about the length from M to N. So once I have NP's length, if I subtract it from 14, I'm going to get MN's length, which is what I want for the base. Okay, Lolita, I hope that makes sense. If not, you're welcome to pop me a message or pop Yolanda a message, and hopefully we can explain that. But I had to subtract it because I only wanted MN's length because that was my base. Okay, guys, I'm hoping we all have screenshots. I want to move down to the next one. Okay, so question D says, the area of a circle is 320 centimeters squared. Determine the diameter of the circle. So let's just think about what this is saying. Okay, apparently I'm going to draw a circle on the highlighter, but that's fine. So it's telling me that the area of this whole circle is 320 centimeters squared. Now, that's cool. This is quite similar to the first questions that we spoke about. But what is important here is that we know how to work out your y. We know how to work out the area of a circle. Now, remember, the area of a circle is equal to pi r squared. So I'm telling you what the area is. I'm asking you to work out the diameter. And even though diameter is not in my formula, what we need to remember is that 2 radii or 2 radiuses make up 1 diameter. So if I can work out the length of a radius, I can just times that by 2 to get what my diameter is equal to. I'm going to get you guys to try this one. Give it a go. See what happens. Remember, a radius is from the center of the circle to the circumference, whereas a diameter is from one end of the circle through the center to the other end of the circle. So hence, 2 radii make up a diameter. So give it a go. I'll give you guys like a minute or so to give it a try. If anyone is feeling up to it and would like to raise a hand to give an answer, please do. Otherwise, I'm going to go through it in about a minute. Remember, diameter is just a length. So there's no unit squared. It will just be in centimeters. And like I say, this is quite similar to the first ones that we spoke about. So if you need, maybe refer back to those first examples to see how we did it, because it's quite similar. And just remember, we're not working out area. I have given you the area. I want the diameter. I know this is slightly tricky, and it's sort of the reason why I'm giving it to you. It's good to have a think and good to struggle through questions sometimes. Remember, I've given you the area. So think about that carefully when you go and use your formula and you substitute into your formula. feel like this has stumped everyone. Okay, guys, let's have a see. Okay, Lufuna was pretty close, but let's check. So area is pi r squared. And we're going to substitute in what we know. So we know the area is 320. We don't know r, which is fine. We can solve for r. Now, guys, remember, pi is a number, which means that we can divide by pi. It's just a number. We just use a symbol to represent it. So because I'm wanting to solve for r, the first thing I want to do is divide both sides by pi in order to get rid of it on the right-hand side. Now, again, some of you might be using pi as 3,14 or 3,142. I'm just using pi as the button on my calculator. It really doesn't matter. All that it will mean is that your decimals maybe are slightly different to mine. Doesn't matter. So 320 divided by pi then gives us r squared. Just going to carry on up here. And 320 divided by pi is 101,859,91636. So this is now r squared. Now I don't want radius squared, I just want the radius so that I can eventually times this by 2. So I'm going to square root both sides to give me just the radius. When I square root that whole 101 blah blah blah, I get that my radius is equal to 10,09, and there's a whole long decimal. Now remember, I want the diameter, so I need to take this amount and times it by 2, because 2 radii make up a diameter. And so the diameter of the circle is 20,16 centimeters. Again, this is a length, so it's not centimeters squared or anything like that. It's just centimeters. And I had to times it by 2 because going back to what we said right at the start with my question is the fact that 2 radii make up 1 diameter. So that is why I times by 2. Right, this was a tricky one. So hopefully this makes sense. Like I say, if you're using 3,14 or 3,142, your decimals will be a bit different to mine. It's absolutely fine. You use the value that you've been told to use at school. I've just used the pi button on my calculator. That's generally what we use as we sort of head into grade 9, grade 10, etc., etc. But obviously, if you've been told to use something specific, that's what you do. Okay, so I'm just waiting for everyone to take a screenshot. And then we're going to try one more before we do our poll. Okay. No. Right, let's try this one. I'm going to leave it to you. The area of the rectangle below is 37.5 centimeters. Determine the value of B. So just so we can all see exactly where B is essentially the length of the rectangle. So I'm telling you what the whole area is. I'm also actually giving you what the breadth or the width of the rectangle is. I want B. So if and when you have an answer, you can put in the chat or you can raise your hand to explain it to us. We're looking for B. Remember what the area of a rectangle's formula is. Remember your units. Give everyone another minute. Remember, it is E, so it's a length. It's just one dimension. So remember your units. Okay, Leah, do you want to explain it to us?
Hi, ma'am.
Hi.
So, ma'am, I said area equals length times breadth because that is the formula for a rectangle.
Perfect.
And then I said E equals 37,5 divided by 5. So B equals 7,5 centimeters.
Perfect. Oh gosh, I'm catching up there. I don't know. Yes, right. Sorry, I've just lost my whole train of thought. Okay, so guys, area is equal to length times breadth. We know that the breadth is 5 centimeters. And so that means that we need to divide the area by 5. That then gives me 7.5 centimeters as my length. Now, if this step over here by the star is confusing you a little bit, think about what happens when you substitute into your formula. The area is 37,5. The length, we don't know, that's B, but we do know the breadth, so times 5. So technically what I have on the right is 37.5 is equal to B times 5, which we know is 5B. Now I don't want 5B, I want B, which means that I need to divide both sides by 5, which is what I'm doing there, in order to get B alone. And so that is where we're getting 7.5 centimeters from, by taking the area and dividing it by the breadth. Oh. Remember, of course, this is one dimension. It is the length. So it's not centimeters squared or anything like that. It is just 7.5 centimeters. And once again, this is an example of a question where I give you the area and you need to work backwards. The rectangle question that we did earlier, where we spoke about triple the length is the breadth, that was definitely a harder one than what this was, because in this one I gave you the breadth, whereas in the other one I didn't. But similar concept, I'm giving you the area, you need to work backwards. So I'll leave this up for a screenshot, but I know we do have the poll. So Yolanda, if you want to put that up, we can definitely do the poll now.
Let's do this, my pips. Y'all did really, really well today. Well done, and all the best to people that needs to do exam.
Yeah,
we are so proud of you, and keep going, my pips. Let's keep voting. Remember, if you do find this class to be really fast for you, you're allowed to change to the foundation class, okay? So meaning you'll have to give either teacher Sam or Yolanda your name and your surname, and then we can suggest that you want to move back, okay? Let's vote, my pips. Let's go, let's go. The numbers is increasing. Lilita, do you have any question? You can ask your question while we are busy voting here.
I just wanted to ask, in what situations do you know that you need to divide a number by pi?
Okay, good question. I suppose one of them would be in a situation like, I'm hoping everyone's taking a screenshot, in a situation like this last question where we're solving for the radius, which is actually the value that's been multiplied by pi. So whenever we're solving for something that's been multiplied by pi, in order to solve for it, we'll have to divide by pi to get rid of it. So it's generally when working out the radius based off of the area or the circumference given to you for a circle, because then I'm giving you the answer that will then need to be divided by pi. Does that make sense?
Yes, ma'am. Thank you.
Good question.